All right, and here's Chris Wright of Red Hat to give our opening keynote. Chris, I'll turn it over to you.
Okay, nothing like landing and coming straight here. All right, thank you for coming. This is actually the second OVS Conf that I've attended, and I believe it's the second one. I'm really honored to be able to do the first introduction and kick this off today. My name is Chris Wright. I'm Chief Technologist at Red Hat, and I just want to share with you some ideas that I have, or musings or general ramblings about OVS. And while this is considered a keynote, I'll be happy to assuming that there's some time at the end, I'd be happy to have a dialogue with the room if we have a few minutes. So I couldn't pass up the opportunity to just acknowledge the deep, disturbing tragedy that's happened in Paris on Friday and Beirut a few days before that. I was wondering what to say about that. To me, the word that kept coming forth was compassion, and I found this quote from an IBM CEO about computers and compassion. So we're here to talk about computer technology, but I think it's important to remember that we're humans, and there's something that we can bring to this world that includes compassion, and I think that's especially important in an open source environment where we're working together as collaborators, building trust, and really leveraging the human relationship that we build inside an open source community. So again, just wanted to acknowledge the sort of gravity of the world today and not dwell on it, but just make sure we're all acknowledging that. So what informs my perspective? I was walking through this with Russell, and Russell gave me some ideas of what might be interesting. So if none of this is interesting, it's actually all his fault. I had really great ideas, but I followed his advice. No, just kidding. My perspective is informed from a variety of points of view. First and foremost, it's from the perspective of open source software. So open source software is something that I've personally been doing for about 16 years. I was originally interested in open source as a developer, like most of you here, who couldn't resist the temptation to dig under the hood. And that temptation is sort of infectious, and once you get it, you can't get rid of it, and that is what builds communities, I believe. That's what gets us so excited and enthusiastic about working together, because we see there's a world without boundaries. You really have access to all the layers of the stack. I was coming from a proprietary Unix world, and when I could dig underneath a system call and see what actually happened, I was thrilled. And then to be able to contribute to an open source project, actually working in high availability with a few people here in this room, I believe, it just really, that's where I caught the bug. I've been at Red Hat for 10 years. Really, that entire time I've been focused on virtualization in some way, shape, or form. So I started working as a developer on hypervisor technology, moving into the I/O path, and up through management and orchestration of virtualization in the data center and clouds. And now at this point, the Office of Technology at Red Hat has a pretty broad view of the world. We have a stack that starts at bare metal and goes all the way up through middleware and applications. My personal interest is still in the area of virtualization, and I spend a lot of time in the networking space and I/O path today. About 7 years ago, I got involved in network virtualization. This was, again, from the point of view of virtualization, the platform, and the I/O path being really problematic in some ways in a virtualized environment. And so First and foremost, it's just basic connectivity, and then we look at things like performance enhancements, and today, the wide world of virtual switching, software-defined networking, and the really critical role that plays in the modern data center. Apologize, it's a little hard to read the font, but hopefully I'll explain these well enough. I started with OVS about 5 years ago. I got an email saying, hey, we want to collaborate with these guys down in Palo Alto. Can you go down on the 5th of July to meet with them? We're going to do a project together. We have a potential joint customer. I said, sorry, the 5th of July is a US holiday. Can we make it the 6th? And I came down and talked with Martine and Jesse and Justin, a couple other folks. I believe Ben was in Portland randomly. That's where I'm from on that particular day. And we started the discussion of OVS, for me, this discussion of OVS. And one of the clear roadblocks to our ability to work together as corporate partners was the fact that OVS was not an upstream project. The user space component clearly was its own upstream, but all the kernel data path was kept out of tree. And that's sort of my personal introduction to OVS. I've also been working in OpenStack. OpenStack is cloud, private cloud, public cloud infrastructure, and the Neutron or then Quantum project in OpenStack was really kind of an initial large-scale introduction of the OVS project to the world beyond just the fact that it's a public project and had some traction within the Zen community. I've also been working in the Open Daylight project. Open Daylight is a software-defined network controller platform, and the core focus for me in that project and the folks that I'm working with at Red Hat is really around enabling OVS. So it's how do we manage and control the flows across an entire data center built out of hypervisor resident OVS switches in the context typically for us of OpenStack. Although certainly, as you'll see in a moment, containers are important as well. The world has changed, right? It's always evolving. And I was working with some colleagues at Intel a few years ago. They're really excited about bringing some hardware support to the market, supporting networking technology specifically, and wanted to see what we could do to introduce technology DPDK, which I'm sure most of you here are familiar with, into the software world specifically in OVS. And there were numerous forks of OVS combined with DPDK. And this sort of initial conversation slowly led to strong encouragement from Red Hat and some other folks in the community that the right way to do this is as a community collaborative project and not as a fork of OVS, but rather bring it to OVS directly. And that, from my perspective, began the integration of these two projects. And then for the last year or so, I've had a few folks working on container networking. And in some sense, container networking is no different from virtual machine networking. Some key differences include scale, the density that you can provide on a host, hosting applications running in containers versus applications running in VMs is easily an order of magnitude improvement. And some of the underlying pieces of how you build connect the container to the actual outside world is a little different as well. But I think it's a really important trend in the industry, and it's got a lot of hype, but it also has some very real practical application and value to developers and to the modern data center. So this is an area where we're looking at, along with some other folks in this room, where we can combine OVS as a building block with container technologies. So that's kind of the technology view or the open source components of what brings, what informs my perspective. As a leader in Red Hat, I have an opportunity to speak with a lot of, There we go. As a leader in Red Hat, I have an opportunity to speak with a lot of partners and customers as well. So those inputs also help form my perspective. And it's interesting that these conversations fall into sort of two different sides or camps. One side, networking is fundamentally the solution that these either users or partners are trying to provide to the market. And that means, from their perspective, they're willing to withstand quite a bit of complexity and pain, really to provide this value to either their end users or their customers, because their goal is to provide some new networking functionality. And that makes them very sophisticated as users and puts them in a really different camp from the other side, which are the people that are just saying, this networking stuff is a pain in the butt, and all I want to do is make it work. And their complexity is really the problem. And connectivity is really key to building applications, especially modern applications are more and more distributed, so connectivity between applications is important. And this is kind of two different worlds that I'm living in, and I'm sure I share that with a lot of people here, where on the one hand, we're interested in introducing new features and complexity, and then on the other hand, we have reasonably unsophisticated users that are just trying to make sense of it all. So I'll reflect back in time a little bit to the beginning of virtualizing the data center. And virtualizing the data center has really fundamentally changed the data center, no surprise. Initially, with server consolidation, what we were really concerned about was just moving an existing server from a physical form factor to a virtual form factor and bridging that server's connectivity into the network. So we focused on L2 adjacency, maintaining essentially the same connectivity that we had before we virtualized that workload. And we didn't really initially have to worry a lot about placement. Things were relatively static. However, as we really fully realized the virtualized data center, we started to see that scheduling and network connectivity weren't actually well aligned with one another. And in kind of the pathological worst case, or the degenerate worst case, you'd see a data center environment where the VLANs that are being used to bridge the virtual machines onto the network are potentially trunked at the top of rack, at each of the ports in the top of rack switch across the data center, effectively collapsing the data center into one large broadcast domain, undoing all the work we did in the physical world to create isolation. And we solved the problem of connectivity, and we're starting to create new problems for ourselves. And of course, that's kind of an opportunity. At the same time, this new layout of workloads and modern applications changing made the physical topology shift from kind of a traditional three-tier access aggregate core, sort of quote-unquote Cisco data center, to a fat tree or close network that has a leaf and spine topology to support the growth in east-west bandwidth or traffic flow. And so, all of these things in my mind are sort of working together at the same time and creating this new environment where we're trying to understand how do we connect applications in a modern data center. The server administrators suddenly are network administrators, and this was a real point of consternation for the network operations team, who's responsible for security for the organization. And now you have some of this east-west traffic is completely skipping the core network and therefore bypassing all security policies. So we have this concern about inconsistent policies. And then with the introduction of virtualization, the virtual I/O path is not as well optimized as the CPU path and the CPU utilization in virtualization. So you have, in some cases, significant overhead where we focused on bandwidth and throughput and offloads, segmentation offloads as an example, for how we could really regain the performance loss, always with this back of mind intention to get back to cycles per packet as a really meaningful measurement for performance. But when we saw reasonable bandwidth with segmentation offload with large streaming workloads, we sort of felt like to some degree our work was done. And certainly that's not been shown, turned out not to be the case. So at the time, that data center was built out of the Linux bridge. As I mentioned, we were using VLANs for traffic isolation, and really that's just bridging to the existing VLAN infrastructure in the data center. It's not necessarily creating anything new like you'd see in a cloud where tenant isolation requires proliferation of the use of some form of a tag to isolate the individual networks. And for KVM, Linux and KVM world, VirtIO was the state of the art for the I/O path. Still is. And at that time, there were some emerging technologies. The emerging technologies that I was sort of working with included SRIOV, or in some cases, a multi-function NIC. Point being, there's more functions than ports on the NIC, so you're sharing resources and hardware. There's this notion of VEPA, or 802.1 QBG, and related to that, VMFX, or 802.1 QBH, which became 802.1 BR. And these were technologies that were very hardware-centric. So we're trying to address the problem that we have performance limitations with virtualization. We had this policy enforcement problem. So if we could just push all of our traffic back to the physical network and instantiate policy as we locate a virtual machine on a particular host and associate that host with the top rack switch port, then we would solve our policy problems and potentially even our sort of throughput issues if we're directly assigning something like a virtual function into a guest. And while that works, it creates a different set of issues. And that in one particular case, that means you're potentially tromboning traffic out to a top of rack switch and back just to communicate between two VMs on the same host. And ultimately, those technologies, with the exception of SRIOV, haven't really been as successful as the software world and the software virtual switching world has been. SRIOV is still a technology that's in use, and especially in use in places where there's really high performance requirements. And the VEPA use case, while still there, I don't see a whole lot of it. And then VMFX, I think, is sort of an integrated part of one of Cisco's commercial solutions. So since I'm not selling Cisco solutions, I can't tell you a whole lot about that one. At the same time, OpenFlow was an emerging technology. And from my point of view, I always considered OpenFlow as an industry conversation starter. So in the beginning, you heard lots of hype about it, and OpenFlow was SDN. And I took this sort of mental stance that OpenFlow is not SDN. OpenFlow is a way to talk about how do we program, create a programmatic interface to the network. And my sense at the time was it's just an implementation or an example of how to do that network level programming. And we'll see. We're still in the emergence of OpenFlow. It's evolving, and we're starting to see other technologies come forth, and then also people looking at how could we take existing network technologies and use them to create the same level of network programmability that we're trying to achieve. So to me, this is where OVS enters the picture. And as you know, I assume you're all here as developers on OVS, it's a very flexible, very powerful, programmable, multi-layer switch. And the initial view from my side was how can we replace that basic functionality that we had in the Linux bridge, where if you consider where the Linux bridge was at the time, it was essentially not programmable. There's a few fields you could alter, or a little bit of state you could configure inside the bridge, but by and large it was a learning switch, and it just worked. It just worked by traffic flow. It didn't have a lot of external interfaces to program how you forward traffic from port to port. So from a programmability point of view, OVS has essentially two agents, an OpenFlow agent and an OVS DB agent. And to me, I always liked the fact that you had these agents. OpenFlow was at least extensible. OVS DB was defined really in the context of OVS. So we had a lot of flexibility in how we evolved the combination of the protocol and the implementation outside of the standardization group at ONF, which to me gave flexibility or speed to the picture, because standards are great for building interoperability between two distinct black box implementations of the same thing. They're critical, in fact, but if you sort of own both sides, you can really move a lot quicker if you're not trying to predefine and document in excruciating detail exactly how everything is going to work until you really know how it works, and then maybe a trailing documentation is actually quite helpful, or trailing standardization. And that's something that we've seen in the OVS world, where you introduce an extension in OVS that creates inspiration for the OpenFlow protocol to evolve. And I think that's a really healthy example of how open source and standards can work together. OVS was also really a champion for overlay network topologies, isolating the virtual network topology from the physical network topology, typically using something like an L2 over L3 overlay, and initially technology or encapsulation like GRE, and later VXLAN, and certainly STT within some of the commercial implementations associated with OVS. And one of the things I wanted to note in the introduction of OVS to the world was, it came out of a long history. I started 5 years ago, but the project itself was already a couple years old, sourcing from some academic work. And that means all of this work had been happening largely out of tree, as I mentioned, from the perspective of the Linux kernel. And getting that code from the out of tree repository to the upstream Linux kernel was a multi-year endeavor. And I always use OVS and Zen as two examples of what not to do when you're trying to work with an upstream open source project, because the worst case scenario from an upstream perspective is you have pressure from the industry to adopt something because it's already been shipped to customers and users. Creates this false expectation on the user's behalf that this is a real thing, creates sort of the wrong incentive mechanism for the people trying to push the code into the upstream, and it doesn't give the upstream community the sense of the normal flexibility or dialogue that you'd like to have to push back and say, this isn't actually done exactly the way we want to see it done. And as a point in that direction, the initial push of OVS hit a lot of resistance. And there was resistance specifically from some maintainers of infrastructure in the kernel maintaining the TC, or traffic classification infrastructure, which essentially has a flexible match and action table management infrastructure or set of APIs. And from their perspective, that's what OVS is. And why would you do this thing all over from scratch? Well, okay, we're doing it differently because we're trying to enable OpenFlow and a whole bunch of performance concerns, and back and forth, and ultimately OVS obviously made it into the tree, but I know the TC guys still haven't given up. And really the point is, it's just the wrong way to go about introducing new functionality into the upstream community. So I'll leave it at that. We'll touch on TC a little bit later, and I think Simon's here somewhere? Orms? Yeah. So we'll talk a little bit about that later today or tomorrow? This afternoon, yeah. So from my perspective, OVS really started to gain traction in the industry in the context of OpenStack. So again, it was already there. It was deployed in a couple of other environments, but it was OpenStack, in my experience, that really brought it to the broader world, and that was in the context of Quantum or now Neutron. And the initial implementation of Neutron was built around some basic primitives, L2 and L3, and essentially two implementations. A proprietary SDN controller plugin, Nicira's MVP, and an OVS plugin, cleverly called Open vSwitch, I believe. And interestingly enough, we're still working on that initial OVS implementation, and much to my regret, honestly, because it's been a source of a huge amount of issues. I've never fully understood how it got started and why the Open vSwitch implementation in OpenStack didn't use the remote programming capabilities that Open vSwitch had, namely OVSDB and OpenFlow. Rather, it used a custom RPC mechanism to then essentially shell out on the host OVS vsctl commands, which that's one way to do it. I don't think I would have gone that route, and I'm sure there were some reasons why, but we're still sort of undigging ourselves out of that complication. And this is maybe another point of reflection on where in the industry are we trying to really use technology the way it's intended to versus using it as a mechanism to promote commercial products. And here, I think OVS is an awesome open source project, and I think that the initial implementation of the OVS plugin really didn't do OVS itself justice. Now, if we roll forward to where we are today, the most recent super user review, or whatever it's called, in OpenStack showed that the Neutron is deployed about 50% of the time with OVS in OpenStack deployments. And that's about 2x the next form of network virtualization in OpenStack. So it's by far the leading mechanism for introducing network virtualization in OpenStack. Again, it doesn't come without pain points. And one of the things that we hear from a support perspective is that it is brittle, it's complex, and there's consistent concern around scalability and performance. And what's interesting in that conversation is people in the industry at large can't really disambiguate the Neutron plugin OVS implementation from OVS itself. And this is where I think it's harmed the reputation of OVS to not have a really first-class implementation, open source implementation support built out of OVS at the base. So we had an operator meeting, an OpenStack operator meeting, I think it was last spring, and there's a long thread in there trash talking OVS. And if you really dig in, every one of the complaints wasn't about the virtual switch under the hood. It was really about the implementation of the plugin and how it interacted with the rest of Neutron and the OVS instance below. But it's, again, this is a place where it's important to take this valuable technology and show it to the world in the best possible way. So one of the things that we hear, since OVS is really largely building overlays, L2 over L3 overlays, that we hear about performance concerns, and it's in the context of the overhead of an encapsulation header. This actually gets worse when you have something like a PaaS system that's trying to do overlays as well, sitting on top of your virtualization platform. Then you have sort of VXLAN, L2 connectivity for these applications that are sitting in containers that are running inside VMs that are VXLAN connected to one another. at the infrastructure level, and you're really starting to get a lot of overhead. And there's work upstream in the OpenStack community to get away from that double encapsulation problem. But even with a single level of encapsulation, we do hear from some customers that this overhead is too significant for their workloads, and or commercial pressure from other vendors saying that's the wrong technology. So it's worth looking at that from a community perspective of how are we building the best of breed open source technology. A couple of things that I wanted to note here about users of this system. Users really care about basic connectivity, which I think we've achieved. They also care about security groups. This is, again, in the context of OpenStack. And security groups, while functional in OpenStack, they were functional out of this sort of hacked-together mechanism combining OVS and Linux Bridge and IP tables. And this is a space where the introduction of contract support in OVS proper should really bring the state-of-the-art forward. And so thank you for that work, and I know our users are looking forward to it. They also are interested in load balancers, and one of the interesting things about load balancers is it's possible to use OVS as a load balancer. You could also use an external load balancer or load balancer in a VM. So one of the questions that comes up for us is how much of this functionality should be directly in the virtual switch in general, not just load balancing, but network functionality, and how much should be isolated into some sort of application, either in a container in the host or in a virtual machine. I think it's an open question. And operators are really interested in scale, so this is an area where we've really just, I think, tapped the surface of how far we can scale the system in terms of the control plane as well as the actual things like encapsulation. And I think one of the I think Ben pointed out in one of his presentations a while ago that while OpenFlow is built around the notion of reactive programming has a whole set of caveats, including scalability concerns. And we look a lot more at sort of proactive or a combination of proactive and reactive programming in a modern context. The telco world has kind of come from nowhere, from an enterprise data center virtualization point of view, and suddenly cares a lot about virtualization. The telco world has a combination of sort of flattening revenues and growing data consumption that is combining to create a sort of a challenging business environment for the operators. And one of the things that they can do is move a lot of the function-specific or hardware-focused function-specific network functionality from hardware to software in a way that allows you to run an arbitrary network function on an arbitrary collection of infrastructure like a cloud, and compute, storage, and networking, general purpose servers. The physical network function to virtual network function migration creates a new kind of pressure point on the infrastructure, says that packet processing performance is critical. And this is where we see the application of DPDK. It's why people are interested. Cycles per packet matter. DPDK world, people are really measuring cycles, which is not the same for the enterprise data center. And it's really a great opportunity for the OVS community to work together with this new industry segment to build, again, a best-of-breed open source technology. Service chaining is a critical feature for that. Vertical and service chaining is something I think we'll hear a lot about right after this, so I won't talk about it too much more. There's another interesting use case for OVS, which is some level of hardware enablement. And we've had these discussions for years. Starting about 7 years ago, we had a meeting in the Portland Linux Con looking at how we can do the Linux Bridge plus Linux Bridge as an interface with callbacks to support random hardware. We've had essentially that same discussion in New Orleans and Chicago around OVS. How can we use OVS as a management interface, a consistent management interface to support different hardware underneath? And that hardware could look like the embedded bridge inside of a network interface card, which at this point they're getting reasonably sophisticated, enough that programming them is interesting. It could be an ASIC, or even in some environments, a fully programmable, MPU, fully programmable environment. So where are we going with all of this? Well, this is open source. We don't have roadmaps. Nobody knows where we're going. But I think we have some ideas, and we have some really cool opportunities ahead of us. And one thing that's important is that complexity really slows adoption. So we heard this a lot from at Red Hat, from our consumers of Open vSwitch in the context of OpenStack. And one basic thing that we don't have, although we will hear talk about it here at the OVS Con, is debugging tools. Where do you get insight into the network when something goes wrong? And understanding people have spent years looking at TCP dumps. They haven't spent years looking at dumps of OpenFlow tables. So where can we give users, especially the less sophisticated users, tools to give them visibility and insight into their network so they know what's happening or how to fix it or where things are going wrong? Extensibility is also important. Extensibility is kind of an industry-wide notion of extensibility here, where we're bringing new people into the community all the time to help grow the project so that it's relevant in many different use cases. And associated with that, growing the community is the concern of forking the project. And this is something that I've been involved in OVS for about 5 years. For about 5 years, I've had urgent phone calls from probably every company that vaguely touches on OVS saying, OVS needs to be forked because those upstream OVS maintainers are impossible to work with. I'd like to say my own personal experience does not resonate with that sentiment at all. Other people that I know at Red Hat specifically and in other corners of the open source world who've worked with the upstream maintainers in OVS have also found it to be a functional upstream. You propose patches, you have a healthy dialogue, patches get merged. But it doesn't stop the concern. And one of the things that pops up consistently, especially in the last few years where we're in this sort of era of foundations, is what do we do about governance? And Justin got beat up at the Open Daylight Summit this summer about just exactly that. Well, what are you doing to establish some industry best practice around governance in the project? And while I don't have an answer, I just wanted to recognize that that's a concern across the industry. And so kudos to the team for being open. And I think this is a conversation that won't go away. There's also new technologies coming along. So eBPF, that we've had a lot of work upstream in eBPF to bring a different type of programmability into the Linux kernel. And there's some discussion here today about how we could work together with eBPF and Open vSwitch. And that's where TC pops back up. Maybe Jamal will get his cake after all. And then I have some questions that I think are interesting to just ponder. First and foremost, could we be done with L2 already? I think L2 has stopped serving us. I think it's causing more harm than good, problems than it's solving. Clearly, we need L2 for basic connectivity. I mean, the protocol works that way. You need some ARP handling. But if we focus on just L2 as the basic connectivity point for an application to the network, I think we may be missing some of the broader opportunities in terms of identifying, simplifying the network and simplifying how we show policy to application developers. So along with that, it begs the question of how much do we want to continue propagating our current use of overlays? And with the introduction, or not the introduction, but with the slow progress of IPv6 and with containers creating a massive explosion in the terms of numbers of applications that are going to need unique IP addresses, we may be at a point where we can start looking at different ways of connecting applications together with L3, and maybe some form of the existing overlays are overkill at this point. I don't know. And another interesting and open question to me is we've gone to great lengths to push functionality to the edge. The core is going to kind of improve in its sophistication, and we may find that there will be a new balance in terms of where functionality is sitting in the core network and where it's sitting out at the edge in servers, especially as servers take on this blurred line of is it a network device or is it a typical server. And in that context, we have the OVN project, which really has shown pushing to the edge and simplifying the programming interface between the centralized controller and the edge as an effective way of evolving and simplifying some of the network complexities. And with that, I'm slightly over time and introducing the next topic, which is OVN. Thank you very much.
Thank you, Chris.